Hello all, in today's video we'll study about merits and demerits of geometric mean. Merits and demerits of geometric mean. Coming to the first merit, it is rigidly defined. The formula for geometric mean is rigidly defined for individual series, discrete series and continuous series. What does this mean? This means that you go anywhere on the earth or in any country, you will be getting the same value of geometric mean because it is properly defined by the help of a formula. So that is the meaning of it is rigidly defined. Coming to the second merit, it is based upon all observations. If you see the formula for geometric mean, it takes into consideration the summation of all the values. Any formula you take, discrete series, individual series or continuous series, it is taking summation of all the observations. That means the value that means the value for geometric mean that you are going to get is going to be based upon all the observations, and that's a merit. Coming to the third merit, it is suitable for further mathematical treatment. This means the geometric mean, once you have calculated, it can be used in other formulas also. Like you have seen in the case of geometric mean for a combined group. You found out that the geometric mean of the combined group is equal to n1 log g1 plus n2 log g2 upon n1 plus n2. That means the values of g1 and g2 which you had found earlier, you can use them to find out the geometric mean of the combined group. Okay, that's why it is said that it is suitable for further mathematical treatment. Next merit, it is not affected much by fluctuations of sampling. Let us consider the same example that we had studied in the previous lecture. You see, now moving these values or these classes up or down won't cause any change in the final value of geometric mean. Why? Because the value is dependent on the summation of fi into log of xi. So moving these values up or down won't change the result for fi log of x, because it is going to remain the same. So it is said that it is not affected much by fluctuations of sampling. This is the merit. And coming to the last merit of geometric mean, it gives comparatively more weight to small items. Okay, what does this mean? See, if you consider the formula for geometric mean of n observations is given by g is equal to the nth root of the product of all the observations. Okay, and you know, in case of product, if you reduce the value of any one observation, the value of the entire product is going to go down. Okay, let us understand this with the help of an example. Okay, now let us take four observations, 4, 9, 16 and 25. Now what is its geometric means? If we calculate its geometric mean, it comes to 10.95. Now let us reduce one of these observations by a small value. Okay, so let me reduce this 9 when we take a new value in place of 9 as 1. Okay, so instead of 9 I have considered 1 now, and if you see, the value of geometric mean comes to 6.32. That means the value of geometric mean has reduced by almost half, but just by changing one value or reducing one value. Okay, but now you'll be seeing what is the merit in this. Okay, so the merit in this case is because of geometric mean giving comparatively more weight to small items, we derive two benefits. One is a balancing effect. Now what is a balancing effect? Balancing effect means one small value in this observations will balance out the impact of extreme values. So suppose if there are a number of extreme values, just one small value will get down will reduce the value of the entire geometric mean. And this is very important in case of skewed distributions in data science or in the presence of outliers. Okay, remember this is very important in data science. This small value is going to cause a balancing effect. Okay, and what is the second merit? The second merit or the advantage that we get is this small change causes a large effect on the geometric mean. Okay, what does this mean? This means that this small value is going to play a lot of significance in the calculation of geometric mean. And where is this important? This is importance in case of scenarios where small values have got large importance or they have got large significance. Okay, in case of data science, if there are some small values whose change you have to monitor with giving it a lot of importance, in such cases you are going to use geometric mean because it is sensitive to magnitude. Okay, remember this, very important in the field of data science. Now coming to the demerits of geometric mean, the first demerit is because of its abstract mathematical character, geometric mean is not easy to understand and to calculate for a non-mathematics person. Okay, let me explain you this with the help of a small example. As you know, geometric mean is the nth root of the product of observations. Okay, so now if I take three observations, 2, 4 and 8. Now, what is the difference in using geometric mean for this, and why can't we use arithmetic mean? So if you see, the difference between 2 and 4 is 2, whereas the difference between 4 and 8 is 4. Okay, so the difference between 2 and 4 is smaller as compared to the difference between 4 and 8. That means they are growing at a different rate. Okay, and if we calculate the geometric mean of this, we get the geometric mean as 4. So what is the meaning of this 4? This the meaning of 4 is that the one number that grew at a constant rate between 2 and 8, and during that period is 4. Okay, so now where is this important? This is important in data science wherever you want to understand trends and patterns in case of a data set. Especially when you are dealing with percentages, rate of changes, ratios. In such cases, you are going to use geometric mean in the field of data science. Okay, but now if you see all this jargon or all these mathematical formulas and this growth rate and everything, it is very difficult for a non-mathematics person to understand. Okay, so it is said that because of its mathematical character, geometric mean is not so easily understood by people from other domains. Okay, so that's a demerit. And coming to the last demerit of geometric mean, if any one of the observation is 0, geometric mean becomes 0. Okay, this is self-explanatory. You know, geometric mean is the nth root of the product of all the observations. And in case of product, even if any observation is 0, the value of the entire product is going to be 0. That's why it is said if any one of the observations 0, the geometric mean becomes 0. And in other than that, instead of 0, if it is a negative, then the value of the entire product will become negative, and so the value of geometric mean that you get will be imaginary. Okay, so that is also not possible. So these two things are also a demerit in case of geometric mean. I hope you have understood the merits and demerits now, and that's all for today. In the next lecture, we'll see what is harmonic mean. Thank you.